Alright, we're still looking at factorising by grouping, and this is how they make it harder. Instead of having the four terms already organised in their kind of group, they've split them up. So here you can see 2p and kp, the 3k and the 6 could be a group. So what we need to do is we need to write things together in groups that can be then factorised. So we can do 2p and kp can be factorised, and 3k and 6 can be factorised, and the plus is going to go in there. So with this one, what we can remove is the p, and we're left with 2 plus k. And with this one over here, what we can remove is the 3, and we're left with k plus 2. Now, even though these are written slightly differently, they're still the same thing, 2 plus k, k plus 2. So we can actually remove them as a common factor, and we're left with the p plus 3. Okay, so if we're looking at this one over here, we need to group them first because it's a slightly harder question. So we could put the m and the n together with this m and q, or the m and n could go with the n and the p. It doesn't matter as long as you can take something out, or as long as you can factorise something in the next line. So I'm going to put the m and the n and the m and the q together, and leave the p and the q and the n and the p together. So from this one, I'm going to remove the m, n plus q, and from this one, I'm going to remove the p, q plus n. Now again, this one, q plus n plus q are the same, so I can take it out, n plus q, and what I'm left with is an m plus p. Okay, now it wouldn't have mattered which way you group them, you would have got the same answer, so why don't you go ahead and try and group them differently. Instead, group the m and the n and the n and the p together, and then group these two together, and you will still get up the same answer at the end.